Shalom to you and welcome. In this video, we will look at transformations and some basic mappings. You will be able to use the terms image, pre-image, mapping, one-to-one mapping, transformation, isometry. So some of these you may know them before, some may be new. I'm sure you've heard about reflection, translation, and so forth. But they are a little different from algebra. So pay close attention to how they are similar and how they are different. So mapping and function. In algebra we do function. So in geometry we do mapping. So the word mapping is used in geometry just as the word function is used in algebra. So each one of them maps an input to output. So, but in geometry, we use different terminology and we write it a little different too. So if we have a function f, so we say x maps to x squared. So x is the pre-image and then x squared is the image. And we use arrow to show this, or we also could write it like f of x, like we do function. But we use the word mapping. So here, a mapping can be map one pre-image directly to exactly one image, or you can have one image, several images, pre-images mapped to one image. For example, here for this mapping, it will be many to one, because, for example, if x is 1 squared will give you 1. If x is -1 squared will also give you 1. See, two numbers, two inputs, you get one output. So that's many to one. So, so here is the clear definition of it. Okay, when each number in the domain is the pre-image, and then the range is the image. Okay. You need to follow the arrow. If you notice in the other one, you see it doesn't always go from left to right. It can also go from right to left. Just watch the movement of the arrow. All right. So this is where mapping is different from function. Okay, they are similar but a little different. So watch it. So for mapping, the correspondence is between sets of points like ordered pair. But in function, the correspondence is between sets of numbers. Okay, so if you see here, this is mapping. So you always deal with sets of ordered pair, x and y, at the same time. So you're given this function t. Okay, it maps x, y to x plus 3 and y minus 6. So what would be the image of -1, 5? Well, replace x with -1, replace y with 5. This is in the pre-image, and do the same thing in the image. So replace x with -1 and then do the operation. Okay, you get -2, and then replace y with 5 and subtract 6, you get -1. So this is the pre-image, then you get that image, and we represent the image of A as A prime. Okay, A prime, and we write what we get. The same thing here. The pre-image is 5, 2. The image is going to be 2x. So it's going to be 2 times 5. And then y, 2 plus 1. Okay. Different operation. And then you get the image, which is B prime. All right. Now, okay, let's solve this problem. If f of x is equal to 3x, find the image and pre-image of 6. Now, 6 is playing double roles here. You use 6 as the image and then you use it as the pre-image at the same time. Okay, so let's do one at a time. So the image in this expression, the image here is x. The pre-image, just the input, is x, and the image is 3x. So let's find using x for pre-image first. So when x is equal to 6, then 3x So f of 6 is going to be 3 times 6. Which is 3 times 6 is 18. So the pre-image. So the image of when 6 is the pre-image, let me write it there. Pre-image. When 6 is the pre-image, you get the image of 18. 18 is the image. Okay, so on the other hand, when 6 is the image itself, when 6 is the image, when 6 is the image, it means when 6 is the image, what would be the pre-image? So then our image is this. This is the image. So we do 6. It has to equal that. So 3x has to equal 6 because 6 is the image and 3x is the image. So we want to find the pre-image, which is x. So we just solve the equation for x to find the pre-image. So x is equal to 2. So when 6 is the image, pre-image is going to be 2. And when 6 is the pre-image, the image is going to be 18.